Right, 2015, and the third differentiation question in the long questions. And here it links into your trigonometry and integration in part E. So the approximate length of the day in Galway measured in hours from sunrise to sunset may be calculated using this function, where T is the number of days after March the 21st. So T, number of days. Find the length of the day on June the 5th, 76 days after March the 21st. Give your answer in hours and minutes, correct to the nearest minute. So all we've got to do in order to find the length of the day, we're going to sub in 76 for our T here and keep it in radians and just read off the answer. And for our T, remember, as you say, sub in 76, the number of days after March 31st. Put this all in our calculator. Just remember, if you want to get to the radians, just go shift mode, 3 is degrees, 4 is radians. And place that into our calculator. Now when you do that, it's 16.84. 16.84 hours. Now here they want to answer in hours and minutes. So the hours and minutes just under the letter B. That gives you 16 hours, 50 minutes. And the next one, find the date. So find the date on which the length of the day is approximately 15 hours. So we want to see the number of days after March the 31st on which the length of the day is 15 hours. So we're working out T, and our answer here is going to be 15 hours. So under our function, our FT, 15, is equal to 12.25 plus 4.75 sine 2 pi T over 365. Now we want to work out T. So get everything else to the other side. So the first thing I would do is bring across your 12.25. Put the 4.75 sine of all that. The next thing I would do is get rid of my 4.75. So again, if I had 2x equals 8, how do I get x on its own? 8 over 2. Same thing here. Here's our x. We want to get this on its own, so bring that in below it. So 15 minus 12.25 is 2.75. Just keep tidying as we go. Over 4.75 is equal to your sine 2 pi t over 365. That might actually simplify 2.75 down to 4.75. No, that's not great. Now, keep in mind, we want to get this t out. How do we get that t out? Now, it's something we haven't seen too much of before. If we wanted to get out of a square root, say, what would we do? We'd square it. It's the same here. We do the opposite operation, do the inverse to it. So in order to get rid of the sine, you do sine inverse. Now you can't just do sine inverse of this side, you've got to do sine inverse of both sides. So sine inverse, 2.75 over 4.75. Sine inverse times sine, that's like square root and squaring. You're just left with what's inside your brackets. So you're left with 2 pi t over 365. Still want to keep this t. So how do we do this? We can get rid of the fraction because it's an equals. Cross multiply. 365 times all of that is equal to 2 pi t. And to get t on its own, divide that all by 2 pi. Just put that in your calculator. So 35.8. 7 days after March 21st, so 36 days after. And if you count that up from March the 21st, so there's 31 days in March, 30 days have September, April, June and November, all the way at the rest of 31. So there's 10 of your days. And then you've got 26, so it's 26th of April. April 26th. Next bit here, part C, find the derivative of ft. So the derivative, the original function, your 12.25. I'll just write out the functions so we can see it. I just put that t in along the top line, makes it a lot easier. So when we diff this, our 12.25 disappears. Slope of any constant, slope of any tangent line to a number is 0. Now when we're doing this, you can apply the product rule if you like. So the first, it's going to be our first term here. That's going to be our second. So it's your first by your diff of your second. Now in order to do the second, you've got a trig function. How do we differentiate trig functions? PFA. Now P stands for power. Is there a power on the trig function? There isn't. Next thing, the function. The diff of your sin function is cos. So cos 2 pi t over 365 times the angle. So we're going in respect to t. So we're left with 2 pi over 365. Now if you were to tidy that up, 4.75 times 2 pi over 365, 4.75 by 2, divide that by 365, you're left with 19 pi over 730 cos 2 pi t over 365. 19 pi 730 cos 2 pi t over 365. So that's our derivative. Next one. Hence, or otherwise find the length of the longest day. Hence means use your previous answer. In this case, our derivative. So our derivative we wrote down is 19 pi over 730 cos 2 pi t over 365. Another way of saying the longest, the biggest, is this word maximum. Now in calculus, we want to find the maximum, the minimum, the longest, the shortest. We know we go dy dx equals 0. Our first derivative equals 0. So in this case, f dash t is equal to 0. So what we're going to do, solve this. Solve it for t. So that's what we're trying to work out. The number of days after March 31st. So we're going to have to solve this equation. Our 19 pi 730 cos 2 pi t over 365 is equal to 0. Want to get this out. So again, if I had 2x equals to 8, how would I get x on its own? 8 over 2. Sorry. In order to solve this, actually, you can 0 divided by that. So cos 2 pi t over 365 is equal to 0 times 19 pi over 730. That's left with nothing. So cos 2 pi t over 365 is equal to 0. Same thing as we had in part B. We want to get this out, the t out. It's trapped in under a cos function. It's locked in under a cos function. How do you unlock it? You do your cos inverse of both sides. So cos inverse of the left hand side, and you're left with 2 pi t over 365 and cos inverse of 0. And that will give you an answer. Cos inverse of 0 is pi over 2. We want to get this t, so t is equal to cross multiply 365 cos inverse of 0 over 2 pi. It's divided in below. Save a wee bit of time. You put that on your calculator. 365 shift cos of 0 over 2 pi. And you're left with 365 over 4 or 91.25. Now that's 91.25 days after March the 31st. In order to work out what date, or how long the longest day is, we've got to sub that into the original function. So you've got to sub it in, f 91.25 into that original function. So 12.25 plus 4.75 sine 2 pi. Now you can sub that in for 92 if you like. Not going to make any difference. 91.25. So sub it back into that original function, the very top line, because that tells you the approximate length of the day, and that's specifically what they asked. And when you do that, you get 16.99, which is 17 hours. 16.99 or 17 hours, the length of the longest day. And the last bit, don't worry, if you haven't done integration, then ignore this part. So if you haven't done that chapter 4 in text and test 7, or whatever book you may be using, don't worry about this. So use integration to find the average length of the day. Now once you see average, we know we're going to be using integration, and it tells you there in integration, and the formula for the average, 1 over b minus a, b over a, f of x dx. Over the 6 months from March the 21st, so that's your day 0 to 184 days after. So 1 over 184 minus 0, 0, 184, and the integral of the original function. It's tricky here integrating that function. So 1 over 184, so anti-differentiation, the reverse. So 12.25t plus 4.75. Now the diff of your sine function is page 26 minus cos 2 pi t over 365 all over what's in front of your x or what's in front of your t, 2 pi over 365. If you want to tie that up a wee bit more, 1 over 184, 12.25, and sorry, this is still between 184 and 0. Oh, and that's a minus 4.75. All you've got to do is sub in 184 for t, and then sub in 0 for t. Take away your two answers and multiply that by 184. So when you do that, you get roughly 2529.84 when you sub in 184 for t minus 2579. So maybe slightly different. I'm just rushing through this in the calculator. You times that, or divide it all by 184, times it by 1 over 184, and you get, see, 15.25. And here again it says to the nearest hour or to the nearest minute. Press your wee button there on your calculator, which gives you 15 hours, 15 minutes.